Let's see how to evaluate limits with Maclaurin series. For that, we're going to be working through the example that we see on the screen here, in which we're simply told, evaluate the limit as x tends towards 0 of e of x minus 1 over x. Well, first of all, if we were to consider the limit of e of x as x tends towards 0, hopefully it's clear that e of x tends towards 1, and the x that we have on the denominator here, well, that tends towards 0. So this entire expression tends towards 1 minus 1 over 0, which is 0 over 0. In other words, we're faced with an indeterminate form. And oftentimes when that happens, and when we're studying limits as x tends towards 0, Maclaurin series will help us evaluate the limit. And here's the whole idea. We've already seen that the Maclaurin series of e of x is given by the following. E of x is equal to 1 plus x squared over factorial 2 plus x cubed over factorial 3 plus x to the power of 4 over factorial 4, and we could carry on forever that way. And now, since we're after the limit as x tends towards 0, we can replace this e of x by the Maclaurin series we have here. And we can go ahead and state that this limit is equal to the limit as x tends towards 0 of e of x, so that's this entire Maclaurin series. So let me quickly copy that. That's 1 plus x squared over factorial 2 plus x cubed over factorial 3, and so on and so forth. And of course we still have our minus 1 on the numerator here, so I mustn't forget to write that, minus 1, and all of that is divided by x. And looking at the numerator we have here, the 1 that we have at the front and the 1 that's being subtracted on the far right-hand side will cancel each other out. So we can state that this is equal to the limit as x tends towards 0 of x plus x squared over factorial 2 plus x cubed over factorial 3 plus x to the power of 4 over factorial 4 plus so on and so forth. And all of that, again, is still divided by x. Okay, now each and every single one of the terms we have on the numerator can now be divided by this x we see here. And so this limit turns into the limit as x tends towards 0 of 1 plus x over factorial 2 plus x squared over factorial 3 plus x cubed over factorial 4, and so on and so forth. Finally, taking the limit as x tends towards 0, we quickly see that every single one of these terms will tend towards 0. And so we'll just be left with 1. In other words, this limit is equal to 1. And that's the answer. And there we go. That's it for this video in which we show how to evaluate a limit with a Maclaurin series.